Hello everyone, my name is Kunal Sagar, Vice President Delivery here at NeoSOFT. Today we will be discussing about how Kubernetes and Open Telemetry helps cloud native applications to scale. It is fairly easy to run a few containers on your local machine or on a single server. But the way containers are used introduces new challenges regarding the operations of the container. The high efficiency of the concept has resulted in the applications and the services becoming smaller and smaller, and you will find that the modern application can consist of a lot of containers. Having a lot of small containers that are loosely coupled, isolated and independent is the basis for so-called microservice architecture. These small containers are self-contained small part of business logic that are part of the bigger applications. If you have to manage and deploy large amount of containers, you quickly get to the point where you need a system that helps with the management of these containers. The problems to be solved can include providing compute resources like virtual machines where the containers can run on, schedule containers to serve in an effective way, allocate resources like CPU and memory to containers, manage the availability of containers and replace them if they fail, scale the containers if the load increases, provide networking to connect containers together, provisioning storage if container needs to persist the data. Container orchestration systems provide a way to build clusters of multiple servers and host the containers on top. Most container orchestration systems consist of two parts: control plane that is responsible for management of containers and the worker nodes that actually host the containers. Over the years, there have been several systems that can be used for orchestration, but most of them are no longer of great importance today. And the industry has chosen Kubernetes as the standard system to orchestrate containers. Here at NeoSOFT, we not only develop apps and solutions, we also manage them for our customers. To manage large cloud-native applications, we choose different flavors of Kubernetes and its managed services available on almost all popular clouds. To observe your applications on Kubernetes, observability stack plays a vital role. Observability is often used alongside with monitoring, but monitoring is only one of the subcategories of cloud-native observability and does not do justice to its scope. The term observability is closely related to the control theory, which deals with the behavior of dynamic systems. The higher goal of observability is allow analysis of collected data. A popular example is the cruise control system of a car. You set the desired speed of a car, which is constantly measured and which can be observed by a person with a speedometer. In order to maintain the desired speed in the changed condition, example, when a driving up on a mountain, the power of the motor must be adapted to maintain the speed. In the IT system, the same principle can be applied for auto-scaling. You set the desired utilization of the system and trigger scaling events based on the load of the system. Automating your system in such a way can be very challenging and is not the most important usage of observability. When we deal with the container orchestration and microservices, the biggest challenge is keeping track of the system, how they interact with each other and how they behave when under load or in error state. Observability should give answers to questions like, is the system stable or does it change its state when manipulated? Is the system sensitive to changes? Example, if some services have higher latency. Do certain metrics in the system exceed their limits? Why do a request to a system fails? Are there any bottlenecks in the system? The higher goal of observability is to allow analysis of collected data. This helps to get a better understanding of system and react to the error state. This more technological side of things is closely related to modern agile software development that also uses feedback loops in which you analyze the behavior of software and adapt it constantly based on the outcomes. To observe your systems, we can use Open Telemetry. Open Telemetry is a set of API, SDK, tooling and integrations that are designed for creating and management of telemetry data such as traces, metrics and logs. The project provides a vendor-agnostic implementation that can be configured to send telemetry data to the backends of your choice. It supports a variety of popular open source projects including Jaeger and Prometheus. The term telemetry has Greek root and means remote or distance, that is tele, and measuring, that is metry. Measuring and collecting data points and then transferring it to another system is of course not exclusive to cloud native or even IT systems. A good example would be a weather station with a data logger that measures the temperature, humidity, wind speed and more at certain points and then transfers it to another system that can process and display the data. In container systems, each and every application should have tools built in that generate information data, which is then collected and transferred in a centralized system. The data can be divided in three categories: log, traces, and metrics. Let's talk about logs. These are messages that are emitted from an application when errors, warning, or debug information should be presented. A simple log entry could start and end a specific task that application performs. Metrics. Metrics are quantitative measurements taken over time. This could be number of requests or an error rate. Traces. They track the progression of a request while it's passing through the system. Traces are used in distributed systems that can provide information about when a request was processed by a service and how long it took. Let's talk about logging. Today, application framework and programming languages comes with extensive logging tools built in, which makes it easier to log to a file with different log level based on the severity of the log message. To make log easy to process and searchable, make sure you log in structure format like JSON instead of plain text. The major cloud vendor provide good documentation on importance of structured logging and how to implement it. Metric. A metric is a measurement about a service captured at runtime. Logically, the moment of capturing one of the measurement is known as metric event, which consists not only of the measurement itself but the time that it was captured and associated metadata. OpenTelemetry defines three metrics instruments today. Counter, a value that is summed over time. You can think of this like an odometer on a car. It only ever goes up. Measure, a value that is aggregated over time. This is more akin to the trip odometer on a car. It represents a value over some defined range. Observer captures a current set of value at a particular point in time, like a fuel gauge in a vehicle. One of the most popular tools for metric management is Prometheus. It is an open source monitoring system originally developed by SoundCloud, which became the second CNCF hosted project in 2016. The Prometheus data model provides 4 core metrics. Counter, a value that increases like a request or error count. Gauge, a value that increases or decreases like memory size. Histogram, a sample of observations like request duration or response size. Summary, similar to histograms but also provides the total count of observations. Prometheus has built-in support for Kubernetes and can be configured to automatically discover all services in your cluster and collect metric data in a defined interval to save them in a time series database. To query data that is stored in time series database, Prometheus provides a querying language called Prometheus Query Language, short form as PromQL. A user can use PromQL to select and aggregate data in real time and view it in the built-in Prometheus user interface, which offers a simple graphical interface or tabular view. Tracing. A trace describes the tracking of a request while it passes through the service. A trace consists of multiple units of work which represents the different events that occur while the request is passing the system. Each application contributes to span to the trace, which can include information like start and finish, name, tags, or a log message. While tracing was a new technology and method that was geared towards cloud-native environments, there were again problems in the areas of standardization. In 2019, the Open Tracing and Open Consensus project merged to form the Open Telemetry project, which is now also a CNCF project. The Open Telemetry clients can be used to export telemetry data in a standardized format to central platforms like Jaeger. A critical element of having an observability stack is cost management. It helps identify wasted and unused resources, choose right sizing, reserve instances, or spot instances. The possibility of cloud computing allows us to draw from a theoretically infinite pool of resources and only pay for them when they are really needed. Since cloud providers don't offer their services pro bono, the key to cost optimization in the cloud is to analyze what is really needed and, if possible, automate the schedule of resources needed. Kubernetes is the go-to orchestration platform when you are running cloud-native applications at scale. Open telemetry on Kubernetes plays a vital role in observing your application and services. It is important to set up observability stack the right way to ensure these apps and services perform at their highest level, bringing in efficiencies and keep the cost in check. We've had amazing use cases at NeoSOFT where we leverage these principles, platforms, and tools to run petabyte scale of apps and services. I welcome you all to have a conversation with us to maximize your ROI. Until next time.